Okay guys, hello, it's me again. So today I'm going to be doing the solutions for your progress quiz, which I've put on your OneNote, which you'll get either today or tomorrow, depending on when I give it to you guys. And so here are just the worked solutions for these questions. Question 1. There's not really enough room on the quiz to do the information, so I'm just going to write it on the side. A letter is selected at random from the word supercalifragilistic. They're feeling very Mary Poppins in this quiz. So find the probability a letter is an S. Well, counting these up, there are 20 letters. So whatever you're going to be is going to be out of 20. It's the number of favourable outcomes over the total number of outcomes it could be. That's probability. So if it's an S, we can see that there are two S's in our supercalifragilistic. So for question 1A, our answer is going to be 2 out of 20. But when we do probability, we always need to remember we have to simplify. We have to simplify to the lowest we can get it to. So that's just 1 over 10. And remember, I like to box my answers, but I'm not going to do it because it's going to quit on me. Question 1B, okay? Question 1B is what's the probability a letter is an A? Well, lucky enough, that is also 2 out of 20. So we're just going to do 1 out of 10 again. Question C. The probability that it is a P, well, there's only one P in supercalifragilistic. So luckily enough, that's just going to give us 1 out of 20. Out of 20 because there are 20 letters. Probability of the letter being, a vowel. Remember, our vowels are A, E, I, O, and U, and so there are 8 vowels. We've got a U, we've got an E, A, I, I. 8 out of 20. Which equals 2 out of 5, taking out that common factor of 4. And then for E, the probability that it is not a vowel, you could figure this out in one of two ways. One way could be to count up all the number of letters that aren't a vowel and then do the probability. The way I'm going to choose to do it is, we know that all probability must equal 1. So the probability of it being a vowel and the probability of it not being a vowel, they must add up to equal 1. So I'm just going to take 2/5 away from 1. And that's going to give me 3/5. And that's the probability that it is not going to be a vowel. Question 2. Now, I know I'm going to be scrolling away from the questions, but I do have them in front of me, so hopefully you'll have them in front of you as well when you're doing these questions. An experiment involves choosing a card from a standard deck of 52 playing cards and recording its suit. Here are the results of the experiment, and you've got your table. What is the experimental probability of choosing a heart? The difference between experimental and theoretical probability, experimental is based off of an experiment. So for example, we know that the theoretical probability of flipping a coin is just going to be 50-50 either way, but you're not going to always get a perfect 50-50 every time. So the experimental probability is based off of the results you observe. And this is what we're going to be doing here. The experimental probability of obtaining a heart, well, it said it's flipped 100 times, so it's just 17 out of 100. B, for a club, well, a club is 29 out of 100. A red card. For those of you who don't know playing cards, the red cards are hearts and diamonds. So you're going to add that 17 and 16. That gives me 33 out of 100. Okay. And then a black card, well, again, you have one or two ways. In a deck, you either have black or red cards, so you could count up the number of black cards divided by 100, or you take 33 over 100 away from 1. It's up to you, but either way, you get 57 out of 100. Easy enough. Question 3. Now this is where we're trying to find the theoretical probability Okay, so it's not based off an experiment, it's just based off of the odds and the fractions of the cards that we have in the deck. So the probability of finding a king, well, for each suit you have one king. 4 suits, that means you have 4 out of 52, because there are 52 cards in a deck, as said in the question. But we know we can always simplify that, so we simplify it to 1 out of 13. Question B, a red king. Well, if there's 2 red suits, then that means there are 2 red kings. So it's going to be 2 out of 52, which is 1 out of 26. C. Okay, we've got part C of question 3. The Queen of Hearts. There's only one Queen of Hearts. Okay, and she is going to cut off your head. That was an Alice in Wonderland reference, if any of you know that movie. In a less embarrassing note, a black 10 or a red queen. A black 10, well, there's 2 of those. A red queen, there are 2 of those. So that means in total, there's going to be 4 out of 52, which again simplifies to 1 out of 13. An ace, again, there are 4 of them. So I'm not going to write the original one, I'm just going to skip to the 1 out of 13. And then F, not an ace. Well, if 1 out of 13 is an ace, all probability must equal to 1. It's going to be 12 out of 13. Because all probability must equal to 1. Question 4. From a class of 50 students, 32 enjoy tennis and 20 enjoy squash. If 3 students enjoy both sports, display this information in a Venn diagram and a two-way table. I'm going to start with a two-way table because I find that to be a lot easier. So we have, I'm just going to write tennis, tennis complement. Then we have squash, squash complement. Okay? Tennis, T being tennis, being people who enjoy tennis. S being squash, being the people who enjoy squash. Okay, so how many people like them both? It says 3 students enjoy them both. So I'm going to put 3 there. We know the total people who enjoy squash is 20. And we know the total people who enjoy tennis, that's 32. So now we can figure out this other column. We know that that's going to be 17 here. We know that this is going to be 29 here. Okay, and we also know that the total number is, 50. So now we're going to have to try and figure out these other ones. Well, by taking 20 away from 50, we get that this number should be 30, and we get that this number should be 18. Alright, so then we know that there's one person that doesn't like either of them. They're just being annoying. So now it's easy enough with this to draw a Venn diagram. Okay, and I'm going to have 2 events. I'm going to have this one here, going to have this one here. Oh, they're actually nice circles for once. So we'll call the red one T and the blue one S. How many people like them both? The intersection, like tennis and squash, that's 3. How many people just like squash? Well, looking back to our Venn diagram, people that like squash but don't like tennis, that's S and T complement, that's 17. This is where it's really important that you get your set notation proper so you can figure out these questions quite easily, because you know you can say it, what's in T but not in S, what's in S but not in T, what's not in them both. People that like tennis but don't like squash, well, that's the intersection of T and S complement. That's 29. And then outside is just 1. And then you see if we were to add all these numbers together now, we'd get 50. 29 plus 3 is 32. Plus 17 is 49. Plus 1 is 50. So you know you've done your information right. Question 4b. The number of people who only enjoy tennis. The people who only enjoy tennis is just what's in T but not in anything else. So that's 29. C. Write down the probability of choosing one student from the group and that student enjoying neither tennis or squash. Well, we know that only one doesn't like tennis or squash. Probability is 1 out of 50. Okay. Question 5. So for question 5, we have been given a Venn diagram and we need to try and find the numbers and the probabilities that they're asking us to find. So A is the number of A intersection B. Now that is the number of elements, per se, that is in both A and B, and that's just 7. Remember, when it has that N in front, so I'll just write it for this one, when it has that N in front, it just means the number that's in whatever event you're asking for. That's the number that's in A. And for the number of A, that's 20. You have to count the intersection and what's not in the intersection, what's in the whole of A. For C, the number of A, B. What is not in A and not in B? What's not in either of them? That's just 5. Looking at your Venn diagram, of course. Got D. Okay, so D, what's the probability of the intersection? Well, first we need to count up what's our total number. 13 plus 7 is 20. 20 plus 8 is 28, and then plus 5 is 33. So you know your probability is going to be out of 33. Inside the intersection is 7, so the probability of A intersection B is equal to 7 out of 33. The number of favourable outcomes over the total number of outcomes. Probability of something being not in A, 13 out of 33. And F, the union, is 28 out of 33. Make sure you've got your sheet in front of you looking while I'm doing these solutions, guys, because otherwise you're going to be totally lost with the numbers I'm picking out. Question 6. Two events A and B are such that the probability of A is equal to 0.7. The probability of B is equal to 0.45. And the probability of A intersection B is equal to 0.32. So question 6a asks us to find the probability of the union. Well, remember, this is using our addition rule, that the probability of A union B equals the probability of A plus the probability of B, take away the intersection, because we would double count it if we were going to count them both. So that is equal to the probability of A, which is 0.7, plus the probability of B, which is 0.45. And then we have to take away our intersection here, because that's what the addition rule states. And that is going to be equal to 0.7 plus 0.45 is 1.15. Take away 0.32, that gives me 0.83. Question B, that asks us to find the probability of A intersection B. Oh, sorry, no, it's not that. It is... Oh, no, it is. My bad. A complement intersection B complement. So what is in A and also not in B? Well, we've just found out what's in A or B, and that's 0.83. So what's not in either of them is just 1 take away 0.83, and that is going to equal 0.17. 2 more questions to go. We're almost there. If you guys are jumping at joy after not hearing my voice in this video anymore. It's okay. Almost done. Again, we've got a Venn diagram, and we're going to relate the information from the Venn diagram. I might draw it this time. It might be a bit more helpful. So let's draw this Venn diagram. Close enough. And we've got 10, 5, 15, and 0. And that's A, and that's B. Okay. So first off, if we want to find the probability of A, first off, we need to try and figure out how many do we have in total. 10 plus 5 plus 15, that's 30. So it's going to be out of 30. So the probability of A is 10 plus 5, which is 15, over 30. And we always simplify probabilities. That's going to be 1 over 2. Probability of A intersection B. So what's common to them both? The intersection is this section here in the middle. Why did I do that in black? That made no sense. This in the middle here. So it's going to be 5 out of 30, which is 1 out of 6. The probability of A given B. Now we're talking about conditional probability. So just to remind you guys of the formula, probability of A given B equals the probability of A intersection B. Screen is wigging out, over the probability of B. All right. What's in both of them? What is the intersection? We just figured it out as 1 out of 6. But since the probability of B is going to be out of 30, I'm just going to leave it both as 30 for now. So that's 5 out of 30. On the bottom is the probability of B. Well, B is going to be 15 plus 5 out of 30. So that's 20 out of 30. And because we know our fractions, we know these two are going to cancel each other out. And so now I have 5 out of 20, which equals, just ignore that L, guys, 1 out of 4. It's not working for me today. All right, and lastly, we've got the probability of B given A. Probability of B given A, which is the probability of the intersection again. But this time we're dividing by the probability of A. Remember, this number that's second is always the one that's on the bottom. Luckily for us, the intersection of B and A is the same as the intersection of A and B, so our numerator is again 5 out of 30. It's our denominator this time that changes, and that's just going to be 15 out of 30. 30s again going to cancel each other out, so we're going to get 5 out of 15, so 1 out of 3. And so now let's ask, okay, well, what's more likely? Is the probability of A given B more likely, or is the probability of B given A more likely? This isn't a question, this is just something I'm posing to you guys. Which one of these is larger? The 1/3 is larger because it's split into 3 parts and not 4. So the probability of B given A is more likely. more likely. All right, last question. Question 8. From a survey of 40 students, 35 like soft drink. 35 like soft drink. 20 like water. And 15 like them both. I don't know who doesn't like water, but obviously some people do, and they're crazy. Display this information in a two-way table. So let's just do water, water complement, soft drink complement. We've been told the total at the start, and we know the total is 40. So let's have 40 there. Oh, sorry, guys. How many like them both? 15. So 15 is going to be here. We've been told that 35 like soft drinks. We know 35 should be here. We've been told 20 like water. We know 20 should be there. Then you can figure out all of this. 20 plus 20 is 40. 35 plus 5 is 40. And then it's easy enough to figure out all the rest of it. In here should be 20. In here should be 5. And what's left over? Well, no one doesn't like either of them. In here is just 0. Question B. Find the probability that the student likes water but dislikes soft drink. So if they like water but they don't like soft drink, that's this one here. So for question 8B, probability of water and soft drink, likes water and doesn't like soft drink, that equals 5 out of 40, simplifies down to 1 out of 8. All right, and they're all the solutions for your progress quiz on probability. Hopefully you didn't struggle that much with finding out any of this stuff, and if you do, maybe you should work on it a little bit more.